Okay, we'll discuss about finding or determining rate law. How to determine rate law? Let us consider the reaction 2NO plus O2 gives rise to 2NO2. This reaction, how do we find rate law? R is proportional to concentration of which substances and what is the power. This rate law, right? And you know how what is the use of rate law? Rate law can be used to find rate of the reaction at any instant of time. If the reaction is happening, for 15 minutes, that is considered 0 to 15 minutes. What is the rate of the reaction at first minute? You can find by using rate law. What is the rate of the reaction in 61st second? You can find by using rate law. What is the rate of the reaction in 72nd second? This one also you can find by using rate law. Now, if you see the reactions, whatever the coefficients you see here, that won't be the same here. And sometimes you will be noticing that there will be 2 or more reactants, but you will be writing only 1 reactant. Right? Now, how do we find it? What should be the power here? That one will discuss. This is completely based on experimental values. For this reaction, the formation of NO2, let us discuss. First one, the first experimental values are given that when the initial concentration of NO is 0.30 mole per liter, initial concentration of O2 is 0.30 mole per liter, then the rate of the reaction or rate of formation of NO2 is 0.096 mole per liter in 1 second. Per second is given. Means on 1 second 0.096 mole per liter of NO2 is formed. You see the change from first to second one. The initial concentration of NO, now we are doing other reaction by taking the concentration of NO as 0.60 mole per liter and the concentration of O2 as 0.30 mole per liter. And compared to the first experiment, here the change is the concentration of NO is taken 2 times. It is 0.30. When you multiply this with 2, you will be getting 0.60. So the concentration of NO taken now, it is 2 times the initial one. Now we check the rate of the reaction, which is nothing but the rate of formation of NO2. The rate of formation of NO2 0.096. When it is multiplied by 4, you will be getting 0.384. So when it is doubled, the concentration of NO is doubled, the rate of formation of NO2 is increasing by 4 times. Now you see, from first to third one, the concentration of NO is kept constant. Concentration of O2 you observe, it is increased, right? 0.30, now it is 0.60. Third experiment where you are starting the reaction with the initial concentration of NO is 0.30 mole per liter. Initial concentration of O2 is 0.60 mole per liter. It means that when compared to the first experiment, you are taking 2 times more the concentration of O2. Now you observe the change in the rate of formation, rate of the reaction. 0.096 multiplied by 2 is 0.192. So when it is increased by 2 times and the concentration of O2 is increased by 2 times, then concentration of rate of formation of NO2 is also increasing by 2 times. Now you observe the change from first to fourth one. It is doubled. Even these also doubled. When these two are doubled, you will be noticing that how many times this is? Nearly 8 times. Right? So based on these values, we will be writing the rate expression. See, when concentration of NO is changed, when the concentration of NO is doubled, the rate of the reaction is increasing by 4 times. And the concentration of NO, it depends on concentration of NO. So in the rate law, you will be writing concentration of NO. Now, even when you change the concentration of O2, when the concentration of O2 is changed here 2 times, the rate of the reaction is changing by 2 times. It means that it depends on concentration of O2. So you should take the concentration of O2 also in the rate law. Now, what is the power? What should be the power? Now you see, when the concentration of NO is doubled, when concentration of NO is doubled from 1 to 2, it is doubled, the rate of the reaction is increasing by 4 times. So here, if it is doubled, when it is 2 times, then R value is increasing by 4 times, then you should take the power 2. So it should be power 2. Understand? Rate of the reaction is increasing by 4 times when concentration of NO is increasing by 2 times. Now you check the concentration of O2. When concentration of O2 is doubled, the rate of formation of NO2 is also doubled. So it is raised to the power only 1. If this is increasing 2 times, then this is also increasing by 2 times. And this is how you will find rate law. You understand? Now the same way, if you take the reaction A changes to B, A is changing to B, for example. If concentration of A is increased by, if concentration of A is increased by 2 times, if rate of the reaction increased by 8 times, the same way, when you are increasing the concentration of A, if it is increased by 3 times, if it is increased by 3 times, if rate of reaction increased by 27 times, then in this case you will be writing the rate law R is proportional to concentration of A to the power 3, because when it is increasing by 1, this is also increasing by 1. If this is increasing by 2, then this is increasing by 8 times, means 2 into 2 into 2. So that is why I am taking the power 3. If this is increased by 3 times, then this is increasing by 27 times. And this is how you will be finding the rate law or rate equation or rate expression. We'll discuss about differential form of rate equation. Differential form means, differentiation means d by dx, d by dt, d by dy, like that. Where rate equation R is proportional to some concentration of A to the power x, concentration of B to the power y, and where x and y, the values of x and y depends on experimental value. This proportionality constant can be removed by taking R equals to K, concentration of A to the power x, concentration of B to the power y, where rate of the reaction is also written as minus d A by dt. If you take the reaction, if this is a reaction A plus B giving rise to product, the rate of the reaction can be written as minus dA by dt equals to minus dB by dt. That is equal to K into A to the power x, concentration of B to the power y. This is known as differential form of rate equation. We'll discuss about some other examples. Let us consider the reaction CHCl3 plus Cl2 gives rise to CCl4 plus HCl. This is the reaction. For this one, the rate expression is given that rate expression is given as rate R equals to K into concentration of CHCl3 and concentration of Cl2 to the power 1 by 2. Here the coefficient of CHCl3 is 1. The coefficient of Cl2 is also 1. But when you are writing the rate expression, you are taking the power of CHCl3 is 1 and Cl2 power is 1 by 2. This is completely based on experimental values. So these experimental values says that when you are keeping the concentration of Cl2 constant, you take some you are doing some experiment with taking some concentration of Cl3 and Cl2. Now from the first experiment to the second experiment, what you are doing is you are taking double the concentration of CHCl3. Concentration of CHCl3 is doubled, then rate of the reaction is also doubled. That is what this value proves. As power is taken 1, if CHCl3 concentration is doubled, then rate of the reaction is also doubled. Next one, if you are keeping CHCl3 constant, concentration of CHCl3 is constant, and when you are doubling the concentration of Cl2, then rate of the reaction will be 1.414 times initial. 1.414 times the previous one. That is what this value gives. So this one we can write only from the experimental values. The second one, CHCOO, CH3, COO, C2, H5 plus H2O gives rise to, which is also known as ester hydrolysis. This will give the product CH3, COOH plus C2H5OH. If you write the rate expression for this one, R equals to K CH3 COO C2H5 power 1 H2O power 0, or you can keep writing H2O. You can write this as K CH3 COO C2H5. So this data gives that the rate of the reaction is completely depending on the concentration of CH3COO C2H5. That 2 to the power 1. It means that when the concentration of CH3COO C2H5 is doubled, rate of the reaction is also doubled. If concentration of CH3COO C2H5, right, ester, if this is tripled, then rate of the reaction also will be tripled. That is why the power is 1. Understand? In this case, when you take Cl2, now when Cl2 concentration is doubled, if Cl2 concentration is doubled, then rate of the reaction will be increasing by 1.41 times, 414 times the previous one. It means that square root of 2 you will take. The same time, when you take CHCl3, when concentration of CHCl3 is doubled, if this is doubled, then R also doubled. If this is tripled, then R also tripled. This is about rate law, determining the rate law.